Reflection in mirrors. The law of reflection. You probably notice your image on the surface of a pool or a lake. If the surface of the water was smooth, you could see your face clearly. If the surface of the water was wavy, however, your face might seem distorted. The image you saw was the result of light reflecting from the surface and traveling to your eyes. How was the light reflected? Determined the sharpness of the image you saw. When a light ray strikes a surface and is reflected, as in figure 8, the reflected ray obeys the law of reflection. Imagine that a line is drawn perpendicular to the surface where the light ray strikes. This line is called the normal to the surface. The incoming ray and the normal form an angle called the angle of incidence. The reflected light ray forms an angle with the normal called the angle of reflection. According to the law of reflection, the angle of incidence is equal to the angle of reflection. This is true for any surface, no matter what the material is made of. Reflection from surfaces. Why can you see a reflection in some surfaces and not others? Why does a piece of shiny metal make a good mirror, but a piece of paper does not? The answers have to do with the smoothness of each surface. Here's that figure they were just talking about up there, figure 8. It says the light ray strikes the surface and is reflected. The angle of incidence is always equal to the angle of reflection. That's called the law of reflection. So what they're saying is as this flashlight shines its light this way and it hits the surface of a flat plane mirror, it will bounce off in this angle. Okay, here's that middle line. So this little angle right here, the angle that it's coming towards the mirror at, is the same angle as the light ray that's bounced off of there. Regular and diffuse reflection. Even though the surface of paper might seem smooth, it's not as smooth as the surface of a mirror. Figure 9 shows how rough the surface of a piece of paper looks when viewed under a microscope. The rough surface causes light rays to be reflected from it in many directions, as shown in figure 10a. This uneven reflection of light waves from a rough surface is called diffuse reflection. The smoother surfaces of mirrors, as shown in figure 10b, reflect light waves in a much more regular way. For example, when parallel rays remain parallel after they've been reflected from a mirror. Reflection from mirrors is known as regular reflection. Light waves that are regularly reflected from a surface form an image you see in a mirror or any other smooth surface. Whether a surface is smooth or rough, every light ray that strikes it obeys the law of reflection. The scattering of light. When diffuse reflection occurs, light waves that were traveling in a single direction are reflected and then travel in many different directions. Scattering occurs when light waves traveling in one direction are made to travel in many different directions. Scattering also occurs when light waves strike small particles such as dust. You may have seen dust particles floating in a beam of light. When the light waves in the sunbeam strike a dust particle, they're scattered in all directions. You see the dust particle as bright specks of light when some of these scattered light waves enter your eye. Here's that figure they were referring to earlier. The roughness of a surface determines whether it looks like a mirror. So figure A right up here is a rough surface. And it shows that as light bounces this rough surface, it kind of gets scattered in all different directions. Okay, and then B shows a nice, you can see this little flat object down here, like a mirror, is very flat, very clean, very smooth. So when light hits it, it bounces off very cleanly. And this is where you can see your image in a mirror. Reflection in a plane mirror. Did you glance in the mirror before leaving for school this morning? If you did, you probably looked at your reflection in a plane mirror. A plane mirror is a mirror with a flat reflecting surface. In a plane mirror, your image looks much the same as it would in a photograph. However, you and your image are facing in opposite directions. This causes your left side and your right side to switch places on your mirror image. Also, your image seems to be coming from behind the mirror. How does the plane mirror form an image? You can see this is referring to figure 11. A plane mirror forms an image by changing the direction of the light rays. The light rays that bounce off a person to strike the mirror. Some of these light rays are reflected into the person's eye. The light rays that are shown entering the person's eye seem to be coming from behind the mirror. Figure 11 shows a person looking into a plane mirror. Light waves from the sun or another source strike each part of the person. These light rays bounce off the person according to the law of reflection. And some of them strike the mirror, and that rays strike the mirror are also reflected according to the law of reflection. Image in a plane mirror. Why does the image you see in a plane mirror seem to be behind the mirror? This is a result of how your brain processes the light rays that travel and enter your eyes. Although the light rays bounced off the mirror's surface, your brain interprets them as having followed the path shown by dashed lines in figure 11b. In other words, your brain always assumes that light rays travel in straight lines without changing direction. This makes the reflected light rays look as if they are coming from behind the mirror, even though no source of light is there. The image also seems to be the same distance behind the mirror as the person in front of the mirror, which is why when you walk towards a mirror, it looks like it's getting closer, and when you walk farther away, it looks farther. Here's two different types of mirrors that we're going to look at too, concave and convex. You can remember concave, like a cave, you can go in a cave. Concave mirrors are ones that usually curve inward. Here we go. Some mirrors are not flat. A concave mirror has a surface that is curved inward, like I just mentioned, like the inside of a spoon. Unlike plane mirrors, concave mirrors cause light rays to come together or converge. A convex mirror, on the other hand, has a surface that curves outward, like the outside of a spoon. Convex mirrors cause light waves to spread out or diverge. These two types of mirrors form images that are different from the images that are formed by plane mirrors. Examples of concave and convex mirrors will be shown in figure 12. Concave mirrors. The way in which a concave mirror forms an image is shown in figure 13. A straight line drawn perpendicular to the center of a concave or convex mirror is called the optical axis. Light rays that travel parallel to the optical axis and strike the mirror are reflected, so they pass through a single point on the optical axis called a focal point. The distance along the optical axis from the center of the mirror to the focal point is called the focal length. That's why when you have binoculars or microscopes, you're always adjusting those little dials to bring it into focus. It's actually moving the mirrors and lenses to the right spot where it focuses at the right length. The image formed by a concave mirror depends on the position of the object relative to its focal point. If the object is farther from the mirror than the focal point, the image appears to be upside down or inverted. The size of the image decreases or gets smaller as the object is moved farther away from the mirror. If the object is closer to the mirror than one focal length, the image is upright and gets smaller as the object moves closer. A concave mirror can produce a focused beam of light, and a source of light is placed at the mirror's focal point, as shown in figure 13. Flashlights and automobile headlights use concave mirrors to produce directed beams of light. You can see here too, like the inside of a light, it has the mirrors around there and it caves inward. So like in a car's headlight or a flashlight, when that light is shining, it directs that beam of light outward. This is a mirror like I have in the back of the classroom by the safety goggles. You see these in stores sometimes too. This is a convex mirror, and it angles outward, so it spreads out, and you can see much wider, larger areas too, and around corners. You see these in the hallways at school as well. So when you're going around the corners, you can look at that mirror and see if anybody's coming down the other hallway. I won't read this page, but we'll just kind of look at that focal point that they were just talking about. So this is an example of a concave mirror, because you can see it caves in here. So when the light shines, so this ray of light is traveling towards the mirror, and when it strikes that curved surface, it bends that light inward. So no matter which beam of light, all light hits, and no matter where it hits on that concave, it'll bounce them back inward. Okay, and then right where all those beams of light come across each other is the little focal point that they talked about too. So that's where it's in focus. Okay. Here's the other one. Convex mirror, just like the one I talked about that are in our hallways and in the corner of my classroom, some stores as well. Convex mirror has a reflecting surface that curves outward. Because the reflecting surface curves outward, a convex mirror causes light rays to spread apart or diverge, as shown in figure 14a. You can see here where here's the curved outward surface right here. And as the light comes, just like I showed before in the concave, this time when the light hits that curved surface, it hits it and it bends them outward. It spreads them out. So it comes, it travels, bounce. It goes away from the surface, so it spreads them out. Like the image formed by a plane mirror, the image formed by a convex mirror seems to be behind the mirror, as shown in figure 14b. Also like a plane mirror, the image formed by a convex mirror is always upright, unlike a plane mirror or a concave mirror. However, the image formed by a convex mirror is always smaller than the object. Convex mirrors are used as security mirrors mounted above the aisles in stores, and as outside rear-view mirrors on cars, trucks, and other vehicles. When used in this way, objects in the mirror seem smaller and farther away than they actually are. When you're actually driving in your car, when you look at this passenger side mirror, you'll actually see these words. Objects may appear closer than they are. As a result, you can see a larger area reflected in a convex mirror. A convex mirror is said to have a larger angle of view than a plane mirror.